Ever wonder why none of these people fall out when they're upside down in a roller coaster loop? The secret is centripetal force. The passenger is literally pushed into his seat by the circular motion of the car. The passenger's body goes in a straight line, obedient to the first law, if the circular motion of the car did not keep getting in his way, pushing him in a new direction. We can show this with a bicycle wheel and a test tube of colored water. As we spin the wheel, the water sticks right to the bottom of the test tube, even when the tube is upside down. The wheel will slow down, thanks to the force of friction, and when it slows enough, the water will spill out. Now it's not moving fast enough to push against the tube with a force greater than the force of gravity. From this simple experiment, one can obtain the numerical value of the acceleration due to gravity. From the following equations, we see that if we know the radius of the wheel and measure the period of the motion just as the water starts to spill out, we can calculate the value for g, acceleration of gravity near the surface of the Earth. In this setup, the distance of the liquid surface from the center of the wheel was 21 centimeters. On the last revolution, before the liquid spilled, the time for a revolution was 0.91 seconds. With equating the weight of the liquid, mg, to the centripetal acceleration, mv squared over r, we obtain that g, the acceleration of gravity, should directly be v squared over r. We know that the speed of the wheel is its angular velocity omega times the radius. Omega is 2 pi frequency, and since frequency is 1 over period, substituting omega in for the velocity, one finds that the acceleration of gravity should be 4 pi squared times the radius divided by the square of the period. Substituting in the values that we obtained, we find that the measured value for the acceleration of gravity is 1001 centimeter per second squared. With the accepted value as 980 centimeters per second squared, we find that we have a 2% error in our measurement for the acceleration of gravity.